Okay, so now we want to look at integrals involving tangent and secant. So there's a few results, first of all, that we need to uh, be aware of as we're dealing with tangents and secants. Okay, so the one main result is that 1 plus tangent squared equals secant squared. So that lets us either convert from tangent squared over to a secant squared, or secant squareds over to a tangent squared, much like we did with sine and cosine. Second, the derivative of tangent is secant squared, and the derivative of secant is secant tangent. So what that means is if I'm going to do a substitution where u is tangent, then I need to have a secant squared laying off to the side. Okay, I need to be able to pull a secant squared out and then be able to turn everything else into tangents if I'm going to do that. If I'm doing a substitution where I want u to be secant, then I have to have a secant and a tangent that I can strip away and leave everything else in terms of secant. And it's going to become an important thing. What about integrals of tangent secant? You definitely need to remember these as well, or at least remember how to do them should you come across them. Tangent x dx. This is just straightforward. Substitution. All right, what you do is let u be cosine x. So you have integral of 1 over cosine x. Derivative of cosine is negative sine. So you need to put a negative with the sine x dx and account for that by putting the negative outside. All right, so that's just a 1 over u integral now. 1 over u to u. And of course that works out to be ln of u, which is cosine x. So the integral of tangent is negative ln absolute value cosine x plus a constant. And then for secant, what we do with secant is we multiply both top and bottom by secant x plus tangent x. And what that does is it miraculously transforms the integral into secant squared x plus secant x tangent x over secant x plus tangent x. Somebody realized at some point that that the derivative of secant plus tangent is just secant times secant plus tangent. So you can see here the derivative of secant is secant tangent. The derivative of tangent is secant squared. Okay, so that when you let u be the bottom, then u is the top. U is the top. And so this is just a 1 over u. And a similar thing works with cosecant. we get that this is the ln of the absolute value of the denominator there. Secant x plus tangent x. It turns out the integral of secant is the ln of secant x plus tangent x. Okay. So these are our basic integral formulas that we need to use, that you need to be aware of, that we can use for working with our integrals involving tangent and secant. Okay, integrals involving tangent and secant. So we need to know both the derivatives. Of course, we need to know this Pythagorean relationship, and we need to be able to work out the integral of tangent and the integral of secant. And that's because these reduction formulas that we had, that we will be able to use, and we will use them, right? Best that can get you down to, well, if you're lucky, you get down to an integral of just dx. But other than that, you get down to an integral that, if n happens to be an odd number, you're always going to end up with an integral of tangent and secant at the end, so you need to be able to work those out. Okay, so that's where we will be turning to in our next videos, is looking at working out integrals involving tangent and secant, and how, much like we can do some of the cosine sine ones together by doing some substitutions and being able to carry the integration through, that's going to happen with some of these tangent and secant ones as well. That's going to be happening with some of these tangent and secant ones as well. Okay, so we'll take a look at that in our upcoming videos.